Right, good afternoon, ladies and gentlemen. Welcome to the ninth series of ARNECC Net Zero Paper Talks. My name is Shahnaz, and I'm going to be the master of ceremony for this event. And thank you again, everyone, for joining us today. I'd like to also extend a warm welcome to our speaker of the day, Mr. Yudiawan Fajar from the National Research and Innovation Technology, or known by its Indonesian acronym BRIN, will be sharing insights from his academic paper titled Navigating Challenge on the Path to Net Zero Emissions, a comprehensive review of wind turbine technology for implementation in Indonesia. Now, as mentioned, this afternoon's talk is part of the recurring ARNECC paper talks, usually held on the fourth Thursday every month, but special this month, we decided to have it earlier. ARNECC, or short for the ASEAN Researchers on Network on Energy and Climate Change, is an academic collective established by the ASEAN Center for Energy. This collective, which comprises scholars, researchers, analysts, and even students, is formed with the vision of being an interdisciplinary forum for discussions related to social, economic, governance, and technical issues related to the energy-climate nexus in ASEAN. The paper talk in which we are in today is part of the perks on being registered as an ARNECC member. So if you are keen to explore and experience all the benefits of being an ARNECC member, please find the link of registration to be one, which I believe will be sent to the chat box by our team. Now, ARNECC Paper Talks is established to provide a broad and dynamic platform for researchers to share their perspectives on energy climate issues and seek diverse opportunities to stream climate awareness through scientific approach. This afternoon's talk is part of that project, aiming to foster a cross-country discussion on net zero efforts across Southeast Asia. To explore other works related to ACCEP, please visit our website at accep.aseanenergy.org. Again, that ASEANenergy.org, where you can find reports, policy briefs, academic paper, etc. related to net zero in Southeast Asia. Okay, so now moving on, I'd like to introduce to you to our moderator for today, Ms. Zahra Zafira. Ms. Zahra is currently an associate research analyst for the ASEAN Center for Energy. Now for the next 35 minutes, Ms. Zahra will lead this afternoon's discussion, as well as introducing our speaker's credentials. So without further ado, I'd like to pass over the stage to Ms. Zahra. Ms. Zahra, the stage is yours.
Thank you very much, Ms. Shanas, for the introduction and also opportunity to moderate today's webinar. But before I start, may I also check whether you can hear my voice clearly?
Yes, you are very audible.
Okay, thank you very much. And yes, as previously mentioned by Ms. Shanas, today's ASEAN Researchers Network on Energy and Climate Change, or ARNECC, paper talk will discuss and also delve deeper into a research paper developed by Mr. Yudiawan Fajar with the title of Navigating Challenges on the Path to Net Zero Emissions, a comprehensive review of wind turbine technology for implementation in Indonesia. So before we start the presentation session, I would like to firstly introduce our expert for today's webinar, which is Mr. Yudiawan Fajar. So Mr. Yudiawan currently holds the position of researcher in numerical analysis and safety maritime at the National Research and Innovation Agency, or BRIN. And in this role, he mainly focuses on conducting research in the topic of computational fluid dynamics and also floating offshore wind turbine. And he also received his master's degree from Kyungsung University in civil engineering. So I think without further ado, I would like to invite and also welcome Mr. Yudiawan to deliver the presentation.
Thank you very much, moderator Ms. Zahra. Is my voice heard clearly?
Yes, we can hear you clearly,
Okay.
Lisa.
Okay, I will share my presentation. My PPT can be seen?
Yes, we can see your share screen now.
Okay. Okay, good afternoon, ladies and gentlemen. My name is Yudiawan. Today I am here to represent my fellow author in representing the finding of our research with the title Navigating Challenge on the Path to Net Zero Emission, a comprehensive review of wind turbine technology for implementation in Indonesia. This research was conducted by several researchers from various fields at the Research Center for Hydrodynamic Technology, National Research and Innovation Agency, BRIN, with collaboration Bina Nusantara University and 11 Maret University. This is outline my presentation. First abstract, second introduction, third methodology, result and discussion, and the last conclusion. The abstract of this study, the Indonesian government aim for electricity supply to reach 23% renewable energy by consumption. Renewable energy consumption by 2025. To support this goal, floating offshore wind turbine are a promising solution to harness wind energy in deeper water. This is due to Indonesia's vast coastline and abundant wind resources, with present significant potential for offshore wind energy development. This paper provides a comprehensive analysis of the trend and challenges associated with FOWT, particularly in Indonesia. From the analysis and data collection, 10 regions in Indonesia have been identified with wind speeds potential exceeding 5 meters per second, with 3 regions showing the best average energy capacity potential. FOWT floater platforms such as SPAR, semi-submersible, and GLP are suitable for depth of 50 until 80 meters. The logistic and installation of offshore wind turbine are influenced by port location, wind farm location, and manufacturing facility. The background of this study, over the year, this clean energy source has experienced substantial growth. If we look in figure 1, it's currently dominated by the select group of nations like UK, Germany, Norway, Italy, France, Japan, China, Portugal. This country account for an impressive 86% share of the global wind turbine capacity. In figure 2, show FOWT historical and projection highlight. In 2022, still dominate for developing FOWT with market. In 2022, UK still dominate for development FOWT with market share 62.7%. But in 2025, according Global Wind Energy Community, market share for the projection development FOWT changed with South Korea dominates, and in 2030 market share can be balanced. Europe also leads with 59% market share, followed by Asia at 29%, and North America at 12%. FOWT contribute 0.2% to offshore wind installation, but it's set to reach 6% by 2030. Based on Indonesia government regulation number 79 of 2014 concerning national energy policy, the target for the renewable energy mix is at least 23% by 2025 and 31% by 2050. However, offshore wind energy is not yet dominant in Indonesia. The current problem is that offshore wind energy remain untapped in Indonesia because investment per megawatt offshore wind turbine remains approximately 50% more costly than onshore wind turbine. In figure 3 is a map of wind power energy potential, where the largest energy potential is in Nusa Tenggara with the power capacity of 10,188 megawatt. In our methodology, we explain the basic of offshore wind turbine, wind potential, transportation, and installation. If we build FOWT, we must to focus two main parts, the wind turbine and floating offshores. So let's discuss the wind turbine first. As we know, there are two types of wind turbines. First, horizontal axis wind turbine and vertical axis wind turbine. Both types have their own advantage and disadvantage. The power generation efficiency of horizontal axis wind turbine is greater than 70%, while vertical axis wind turbine have a efficiency around 50 until 60%. So the best choice for floating offshore wind turbine is horizontal axis wind turbine. Figure 5 show the development of the size and power capacity of horizontal axis wind turbine, indicating that as the power capacity increase, the rotor diameter become large and the tower higher. For example, if we want to build a wind turbine with capacity 7 megawatt, the the higher tower approximately 100 meter, and the rotor diameter approximately 140 meter, like that. After understanding the type of wind turbine, we then move the type of floating offshores. According to Bosland Engineering and Consulting up to 2022, the most commonly used type of floating offshores is the monopile. Because it's a lower cost and quicker installation compared to other types. In figure 7, show that monopile, tripod, and jacket types can be only used close to the shore. But a barge, semi-submersible, spar, and tension leg platform can be used in water deeper than 30 meters. To understand FOWT, it is essential to collaborate across multiple disciplines, as each component of FOWT require different expertise. As so in the image, there are 5 main disciplines involved in the building on FOWT, like aerodynamics, hydrodynamics, control system, structural dynamics, and mooring. So we discuss about aerodynamics first. The wind turbine section requires knowledge in aerodynamics, including rotor and tower design. Once the design is complete, it is typically verified using numerical simulation and experiment. And in Indonesia, we have this facility. In BRIN, in my office, we use usually ANSYS for simulation and wind tunnel for the experiment. The name wind tunnel is Indonesia Low Speed Wind Tunnel, ILST. After determining the wind turbine design, it is necessary to understand its control system. The same with the aerodynamic. Usually we use to simulation and experiment for the verification before we build the demonstrator. So for simulation we use ANSYS Maxwell, and for the facility usually we use instrument and electronic test facility in BRIN. After that, we must know about the structural dynamics. It is crucial to access the structural strength of the wind turbine. This involves a compression or load test joint system. The structural design is verified through numerical simulation and experiment. And also in BRIN, we have this facility. Usually we have we use ANSYS also and Abacus. So for simulation and for experiment, we have the facility, load test facility. After we focus on the upper water, so we focus below the water. This is the discipline. This discipline is hydrodynamics. The floater section requires expertise in hydrodynamic, including floater design. In BRIN, we have this facility for simulation using ANSYS or Maxwell. And for the experiment, we have seakeeping and maneuvering ocean basin. Same with hydrodynamic for mooring. We have we use two facility to verify the mooring for the floater offshore wind turbine. After we know about the basic fundamental of floating offshore wind turbine, we discuss about the wind energy resource feasibility in Indonesia. The national renewable energy until 2022 had only reached 40.11% of the target 23% in 2025. Hydroelectric power plants still dominate at 60%, contributing to the EBT mix level. while wind energy account for less than 2%. In the table 2, this is the wind power density in various locations indicated favorable wind condition. If the average wind speed in Indonesia is around 5 meters per second, it falls into the intermediate category with wind power density around 75 until 150 watt per meter square. In figure 8, it can be seen that until 22, the average wind speed in Indonesia, especially around the coast, range from 4.1 until 5 meters per second. However, in some area like southern West Java, Nusa Tenggara, and southern Papua, wind speed exceed 5 meters per second. According to table 2, this area fall into the intermediate and good category. After we discuss about wind potential in we discuss about the transportation and installation. It is also important to understand the suitable transportation and installation method for Indonesian water. According to various reference, there are 6 common types of transportation used transporting and installing FOWT, such as tugboat, crane barge, heavy lift cargo vessel, jack-up barge, purpose-built jack-up vessel, and semi-submersible crane vessel. And for installation, because the size of FOWT is very large, we must divide it into several parts. As shown in figure 9, there are 5 options for transporting and installing FOWT. For example, the first option divided tower into 2 pieces and the plate not connected with hub. Or if we choose the second option, the tower become 1 pieces and the plate not connected to the hub. Or we choose the third option, the tower in 1 pieces, 2 plate connected with hub, become bunny air, and the third plate not connected, like that. Based on the reference explanation in the previous slide, we can determine the wind location, floating type, wind turbine specification, and suitable transportation and installation according to the condition of Indonesian water. So first, we determine the wind location in Indonesia. There are 10 locations with an average wind speed above 5 meters per second. The top three location is South Sulawesi, Maluku, and Nusa Tenggara, with potential capacity above 500 megawatt. After we know the wind location in Indonesia, we can determine the floating type Indonesia. The average depth of offshore water in Indonesia ranges between 50 until 80 meters. Making the suitable floating types is tension length platform, semi-submersible, and spar buoy. And then, after we know the wind floating offshores, we can determine wind turbine specification. Given that the average wind speed above 5 meters per second, the appropriate wind turbine specification range from 0.75 megawatt until 7.5 megawatt. This specification align with the tested NREL, National Renewable Energy Laboratory in USA, where a 0.75 megawatt wind turbine has a cut-in wind speed 3 meters per second. This is reliable with average wind speed in Indonesia. After that, we can determine the transportation and installation. Among the various types of transportation suitable for Indonesia is a jack-up barge or SPIV, because there is sufficiently large transportation capacity. For the installation of our FOWT, it is divided into several sections that will be assembled near the coast or port and then towed by the vessel. So the conclusion in the study, Indonesia has quite large wind potential. There are 10 areas that have an average wind speed exceeding 5 meters per second. The average water depth in the selected area is around 50 meters, so the best choice floater types are spar, tension leg platform, and semi-submersible. Wind turbine specification with capacity starting from 0.75 megawatt can meet Indonesia wind speed condition, because average wind speed condition in Indonesia is 5 meters per second. Large turbine capacity increase installation cost and complexity, but operate at lower RPM, making them suitable for a wide range of region. There are two types of installation vessels that are suitable from Indonesia water, such as the jack-up barge and SPIV. Future research, we hope, should focus on creating a demonstrator scale model to validate simulation result and laboratory scale testing, as well as building facilities such as suitable port location and transport vessel to support the development of FOWT. Before I finish my presentation, I would like to highlight that our research. However, the results are still far from being ready to for immediately implementation, because we are still conducting studies, the condition in Indonesia, and of course, the limited funding. Here are some photo of our activity from 2023 until now. This is progress output in 2023. First, we create a design of floater offshore wind turbine. After we create a design, we simulation numeric using ANSYS facility in BRIN. First, we want to know the flow in the rotor blade. After that, we want to know the structural dynamic in the floater offshore wind turbine. Focus in blade, connecting blade with hub. After that, we make the build model test for the testing in wind tunnel. Usually, this facility is in Indonesia. And this is the video footage of wind tunnel testing. Maybe I am play. Is waiting. Yeah. We're at a speed of 10 meters per second. The rotor blade has not yet been rotated. The new rotor blade rotated starting at speed approximately 10.6, I think. Yeah. Yeah. 10.6 start rotating. This testing with variation with speed until 15 meters per second, and the scale model is 1 divided 82 from the original scale. Maybe I stop because the duration is limited. I think this is my end for my presentation. Thank you for your attention. I return into the moderator. Thank you.
Yes, thank you very much, Mr. Yudiawan, for your wonderful presentation on your findings from your paper on the implementation of offshore wind turbine technology in Indonesia. I think the research paper indicates so many insightful findings and also a new perspective, especially by providing a comprehensive list of trends and also challenges associated to floating offshore wind turbines, and also connecting it with the Indonesia's case and also situation to find the best and most suitable options to address all the challenges related to its implementation and development. And I think aside from the technical side, I also believe that the paper also provides very valuable insights by identifying the potential sites for the wind energy generation, as well as it can also give many insights to shape the policies and also strategies to accelerate the development of offshore wind turbines in Indonesia. So now, after the presentation from Mr. Yudiawan, we will move on to the Q&A section. But before we start the session, I would like to invite all the participants to also ask and raise questions based on the previous presentations from Mr. Yudiawan. So if anyone have any question to ask, please feel free to write your questions in the Q&A feature in the Zoom, and we will try to read and also answer the questions during this session. Yes, and I think we already have several questions, actually, maybe starting from the first question, which is from Jihan Asyabani. So, dear Pak Yudiawan, I have two following questions. Do you have any data about the variable distribution and the annual energy production for the selected locations, considering that 5 meter per second is very close to the cut-in speed? I'm afraid that the annual energy production is not enough to reach the economical value, considering the construction of floating offshore wind turbines is a lot more expensive. And then the second question is, how do you think that the potential for turbines more than 10 megawatts to increase the economic viability of floating offshore wind turbines in the country? Yes. So the question is very technical, but maybe Mr. Yudiawan can help to answer.
I will try because it's a very good question and maybe hard question also. Yeah. From any data, maybe for now I cannot I have not data because this data I get from the what is the English is BMKG. Miss Sarah, can you help me what BMKG itu bahasa Inggrisnya apa ya, Bu? Maaf. Meteorology and Geological Agency. Yeah.
Yes.
Because the data is secret for us. So if this is the data years 2015 until 2019. So the data is not complete for us. So I'm sorry, I don't have the data about the variable distribution. And of course, 5 meter per second is very close to the cut-in speed because approximately wind turbine, if like I explained before. I'm sorry. Okay. Okay, please waiting. Yeah, I'm sorry. Yeah, in table 4, this is the specification of wind turbine from NREL. Because in Indonesia we don't have any standard for wind turbine, so I benchmark with NREL. So of course, right, 5 meter per second is very close because approximately wind turbine cut in with speed 3 meter per second. This is a start with capacity specification wind turbine 0.75 megawatt. So this is a challenge for us. Maybe we can build the wind turbine until 10 megawatt. Maybe we start build wind turbine 1 kilowatt or 2 kilowatt. Maybe start with that, and maybe we can build like wind farm like that. And the second, how do you think the potential for wind turbine above 10 megawatt to increase? Yeah, I think it's feasible, but the cost for the high the build this FOWT is very higher because if we build 10 megawatt, we must to the rotor diameter is very big and the height of the tower is very big also. So the cost is very high. But there are many there are other solution. Maybe we can build some wind farm with the capacity wind turbine 1 kilowatt, but the amount of wind turbine is 10. So one kilo of 10. This is equal with 10 megawatt. This is idea. Maybe I think maybe my answer like that. I come back to Ms. Sarah.
Yes, thank you very much, Mr. Yudiawan, for your question. For your answer, and also thank you, Ms. Jihan, for the question. And yeah, maybe just to conclude the answer then for the first question regarding the data. For now, Mr. Yudiawan don't have any complete data because of the confidential issues, and then Indonesia also still don't have any standard for the wind turbine. Hence, maybe we can the conclusion or recommendation maybe is that we can put or build the wind turbine for 1 kilowatt, but in a wind farm and build several wind generation like that. And then for the potential to increase the turbine to more than 10 megawatts, from the cost side, to build the floating offshore wind turbine is also very high because the bigger the wind turbine, meaning the bigger cost it will be. So previously, Mr. Yudiawan also proposed some recommendation, which is to build a wind farm using the 1 kilowatt for wind turbines, but building several wind generation there in the wind farm itself. Yes, and then maybe moving on to the next question, which is from Sarpaneswaran. So thank you, Pak Yudiawan, for the comprehensive review of the wind technology in Indonesia perspective. My question is, first one is the development and installation of wind turbines require significant capital investment. This include the cost of turbines, infrastructure, and grid connection. However, the investment per megawatt offshore wind remains approximately 50% more costly than onshore wind. So what are the existing green funding mechanisms available in Indonesia to kick off such project?
Yeah, thank you, Dr. Nes, for your question. It's a very interesting, very good question also. Yeah, floating offshore wind turbine, the very high cost. So in Indonesia now, the regulation for offshore wind turbine is not specific. Is not apa ya, belum disusun ya. Is not bidden to my government just focus in the solar panel and the tidal, because my government in Indonesia, the sun, the solar panel is very easy to installation also, and the cost is not very high if we build a floater offshore wind turbine. But for offshore wind turbine, we have in some area in South Sulawesi, in Caniponto, I think, but not higher, just only I'm sorry, I am forget the data. But in Indonesia, the government development the solar panel, the tidal, and wind turbine source like that, Mr. Sarah.
Okay, noted, Mr. Yudiawan, for the question, for the answer. I hope that that can also answer the question. But maybe to also give more clarification and also follow-up question, because it is actually a very interesting question regarding the green funding mechanism. So from your opinion and also your knowledge in Indonesia itself, is there any specific funding mechanism or funding policy that Indonesia already implemented for the offshore wind development itself in Indonesia? Or probably if there's not, maybe you can also propose some kind of explanation or example of what kind of green funding mechanism that do you think will be applicable for Indonesia?
Yeah, because in Indonesia, for a floater offshore wind turbine, the finding is I think there is no funding for this study for a floating offshore wind turbine. But if solar panel like that, energy of sun or of the tidal, the funding is ready in Indonesia.
Noted, Mr. Yudiawan. Thank you very much for the answer. And I hope the answer also answers the question from Dr. Naish from CNG Analytica. And then for the next question is from Marcel Manulang. So how can the choice of vessel and its specific technical features such as crane capacity, transit speed, and jacking up speed impact the sustainability and overall efficiency of transporting and installing wind turbines in Indonesia, given the varying wind turbine specification and the average minimum wind speed potential of 5 meter per second in the region?
Yeah, thank you for the question, Mr. Marcel. In Indonesia, there is no choice of vessel for transportation of installing floating offshore wind turbine because there is no study or research about that, and there is no standard in Indonesia about the transportation because my government always focus in the onshores. So this is the data I bring for the capacity large. So I just focus in the how the vessel bring part of the floating offshore wind turbine. How many kilogram or how many ton this vessel can be bring the part of the floating offshore wind turbine. Because in Indonesia there is no standard on information about the vessel. And what given the
Yes, and the second question is given the varying wind turbine specification. Oh, yes, I think it's only one question
only one
actually.
question, yeah.
Yeah,
Okay.
about the choice of vessel and also considering the varying wind turbine specification and also average minimum of wind speed potential. Yes, and I think overall it's already been answered by Mr. Yudiawan that for now there's still no standard on the transportation and also on the vessel, the choice of vessel itself in Indonesia. So and then the next question is from Mr. Muhammad Furqan. So the question is, what is the challenging to implementing this wind energy for supply electricity? So it's more into what is the challenge of implementing the floating offshore wind turbines in Indonesia?
Yeah, the challenging implementation wind energy in Indonesia, first maybe the cost of funding also. After that, the collaboration with industrial because because the regulation for the build something in Indonesia or example wind turbine in onshores, we must to build in Indonesia, not in other outside Indonesia. So we must to know the industry in Indonesia have a capability to build the wind turbine. And third, maybe the transportation, because location in Indonesia, location wind location, wind location in Indonesia, it's very difficult to access the location. So this is the challenges. The transportation is always one of the important challenge in Indonesia. I think my answer like that.
Yes, very fully noted. And I think it's also mentioned and also highlighted in the study itself, whether the challenge itself very relies and heavy on the cost itself, the cost of the floating offshore wind turbines development, and also related to the policy, including what you mentioned before regarding the collaboration with industrial, and then also regarding the transportation because of the location of wind energy and the wind energy in Indonesia itself. And then I hope that also answers the question from Mr. Muhammad Furqan. And then moving on to the next question. So from Mr. Muhammad Rafli. So there are six questions actually. Yes. So the first one is regarding the RE target, I think. Is the 23% target still relevant? I believe the government changed the target to 70% by 2025 recently. And then regarding the figure that you included in the study itself, how did you check the wind speed in figure 10? And is it from Wind Atlas? And then the third one is 0.75 megawatts for offshore wind is pretty low actually, where usually the installed floating offshore wind turbines has a capacity of more than 10 megawatts. So do you have any info on the cost, maybe related to CapEx or LCOE? And then the next question is related to any plans to push the responsible minister or government to put this into action so that we don't stop at the potential study itself. So yes, maybe you can answer
I
from
will
the first
try.
question first.
This is a interesting question.
Yes,
Thank you, Mr. Muhammad Rafli. For the answer in the question first. Yes, this is not relevant because this data I get the 2023, so I think it's not relevant for now because next year is 2025, but the target are not achieved until 23%. Yes, I agree. The target government Indonesia changed the target become if I remember or not, 17 or 18 like that. So yes, in my paper because I am get the data in before 2023, so I'm not update in my paper. So thank you for your correction. And second, the answer is how did you check the wind speed in figure set? It is from Wind Atlas. Okay. This is I am get the picture and the data from my my collaboration, my colleagues. So maybe I will to check my colleagues this data is updated or not. But this data this data I get in the 2023. So maybe the data not updated. And the answer number 3, 0.75. Yeah, 0.75 megawatt low, very low. I agree. But if we build the large capacity above 10 megawatt, the cost is very high. So I think the government in Indonesia not support like that. So maybe the solution is we build below 10 megawatt, but we built several wind turbine. So maybe like a wind farm like that. And fourth question, I'm sorry, I cannot information about the cost of CapEx or LCOA. I'm sorry. For answer 0.5, we try to discuss with Ministry of Energy and Ministry of I'm sorry, Kementerian Keuangan juga, Ministry of Funding, because this our research like I show you funding at Ministry of Finance in Indonesia, but the funding is not big, so we must to other solution with the limited funding, how we can make the floating offshore wind turbine, but maybe capacity below 1 megawatt, or maybe how the solution. we must try always. We must try to responsibility. Kita discuss with the ministry, industry, but not industry interesting with the floating offshore wind turbine because the cost is very high. And number 6, thank you for your suggest. The keyblade, if I read reference, it's very good for the rotating blade, like in FOWT or rotating any in the plane, maybe. But I will try. Thank you for your suggestion. I think enough, Mr. Sarah.
Okay, thank you very much, Mr. Yudiawan, for your comprehensive answer, and also for Mr. Muhammad Rafli for the questions. And I think the next question is actually also relates to the financial topic related to investment, which what you already explained before. But maybe if you want to give further clarification and also information, because the question is related to what are the financial challenges with wind energy turbine projects.
Yeah, for the financial challenge, this is a challenge for the funding for this study or the research. For our study, our research, we get funding from Ministry of Funding in Indonesia, but the funding is not good. I mean, because before we get the funding, we presentation in the Ministry of Funding, but the the response is not good. So it's very far to implementation in Indonesia. Is the cost is very high. So the research, I think cannot continue with implementation fast in Indonesia. So we have to collaboration with university and maybe with industry, but until now we can found the industry interesting with our research, just university interesting with our research. So the funding is still not enough to research about floater offshore wind turbine, but I hope next year we can find the funding in order. Maybe we try to international funding. We try to next year we try to international funding. I hope we can get the funding. Thank you.
Okay. Yes, thank you very much, Mr. Yudiawan, for the answer. And then, yes, I think to conclude, related to financial challenges that we face in Indonesia itself for the implementation of floating offshore wind turbines, mostly related to because the government right now is still focusing much more on the solar PV because of the lower cost for installation and also initial investment. And then the next problem is also because from the industry side itself, there's still not too many industry that focuses and also interested in wind turbines because of the high cost and also investment itself. Yes. And then maybe lastly, just to close our Q&A session, because unfortunately we have limited time available. So hopefully that the rest of the questions can also be answered later on if you can, or you want to directly approach maybe Mr. Yudiawan after the event. But for the last question is related to the materials, which is a question from Ms. Aradia Rula. What kind of materials is used to make the turbine to have a good protection because it is near to the water?
Yeah, thank you, Ms. Ardia Rula. The kind of material is using the aluminum grade for marine. So because if we use a composite, there is no study about that for the implementation in water, sea water. I mean sea water in Indonesia because there is no study or research about that. So maybe for the implementation right now, maybe the aluminium marine grade like that. Yeah.
Okay, noted. Thank you very much, Mr. Yudiawan, for the
Yeah, thank you.
answers. And again, also thank you very much to all of our participants for your very active participation during the Q&A session. However, again, due to the time constraints, we must cut short for today's Q&A. However, before we end this session, I would like to give an opportunity to Mr. Yudiawan to give a brief closing statement to end our insightful discussion and also webinar today.
Wah, saya belum nyiapin juga sih Mbak closing.
Just a brief
Okay.
closing statement, maybe Mr. Yudiawan, just to conclude and also to highlight the output of your research and your hope for future for the floating offshore wind turbines development, maybe.
I hope there is support government and any other pakai bahasa Indonesia boleh nggak? Saya kok agak ngeblank, mohon maaf Mbak. Ya, saya berharap sih nanti mungkin minta tolong diterjemahkan ya Mbak Sarah ya. Kami berharap studi kita tidak berhenti sampai tahun ini. Kita mencoba untuk tetap ada dari tahun ke tahun, meskipun tidak disupport oleh pemerintah, tapi kita akan mencoba mencari jalan dan akan membuktikan bahwa sebenarnya Indonesia itu bisa membuat floating offshore wind turbine. Mungkin itu Mbak Sarah. Maaf ya Mbak.
Yes, very well noted. And maybe just to echo it again, what Mr. Yudiawan just said, that we also hope that the study doesn't end here, doesn't end just as a study, or yes, just a preliminary study, but also to further improve and also implement and develop our own floating offshore wind turbines in Indonesia. And yes, to close the session, I would also like to give just a brief summary based on Mr. Yudiawan's presentation and also the discussion that we have during the Q&A. So I think during the presentation, we see that Mr. Yudiawan already presented the paper where he investigated the potential for developing floating offshore wind turbines in Indonesia, where it evaluates not just the country's readiness to implement this technology, which is based on examining the technology and then economic and also regulatory challenges. And additionally, it also provides a very comprehensive analysis on the global floating offshore wind turbines trends and also identifies suitable technology based on Indonesia's situation and also characteristic. And again, just to echo what we have discussed before, we can conclude that Indonesia itself has a very substantial potential for floating offshore wind turbines, but achieving this potential will require addressing many technological, economic, and also regulatory challenges, and the need to adopting regional best practices and also overcoming the specific technical and also finance problems. So I think overall Indonesia will need to further develop the policies and also regulations to support the development of floating offshore wind turbines, including also the enhancement from the investment side and also from the technical research like what Mr. Yudiawan is doing right now. And in the end, the successful implementation of the floating offshore wind turbines itself will also significantly contribute to Indonesia's renewable energy goals and also the overall energy security. So I think that will be all from me today as the moderator for this ARNECC paper talk. Again, thank you very much, everyone, for your participation and also for our distinguished speaker, Mr. Yudiawan, for the very insightful presentation on your research paper. And to end this webinar, I would like to pass the session back to our MC, Ms. Shahnas. Again, thank you.
All right. Thank you so much also, Ms. Zahra, for moderating the discussion. I'd like to also again extend my heartfelt gratitude for Mr. Yudiawan for the insights shared today in regards of navigating challenge on the path to net zero emissions, a comprehensive review of wind turbine technology for implementation in Indonesia. Moving on, the next agenda would be a photo session between our speaker, Mr. Yudiawan, and moderator, Ms. Zahra. So to Mr. Yudiawan and Ms. Zahra, please be ready and give your biggest smile to the camera. Okay, think for the ICT, can you please spotlight our speaker and moderator? Or let me just, yep, all right, perfect. Okay, perfect. I will lead now the countdown. So 3, 2, 1, smile. Okay, come on. Okay, let's do another one. Right. 3, 2, 1, smile. All right. Okay, that will be great. Okay, so thank you so much, Mr. Yudiawan and Ms. Zahra. To Mr. Yudiawan, thank you again for lending your precious time to share your comprehensive technological review of floating offshore wind turbines in Indonesia. This topic is especially relevant to increase offshore wind deployment in the country, given by its high potential and recognition of its role to fulfill Indonesia's RE targets, and by extension, the achievement of RE share and installed power capacity targets set by the APAEC or the ASEAN Plan for Energy Cooperation. We hope that the discussion today can be of thought for the audience, as well as an aid to create further productive discourse in the floating offshore wind turbine deployment in Indonesia. Finally, this event has approached to its end. Thank you, everyone, for attending, as well as your lively questions. We will see you again in the next episode of ARNECC Paper Talks, because as a gentle reminder, ARNECC Paper Talks will be held monthly on every fourth Thursday, which means that we might see each other again in August. So stay tuned to our social medias, newsletter, and website to obtain more information in regards of ARNECC Paper Talks, as well as all things net zero in Southeast Asia. Hence, I will bid you all goodbye and have a wonderful afternoon. Bye-bye.